Okay, hi everyone. Now I'm going to talk about topic 15, which is annuities. So when we talk about annuities, I think it's just really important to understand like the basic definitions. So annuity is the difference between this and what we were doing with compound interest is with compound interest we had some principal amount that we were depositing. The difference with an annuity is that we have an amount that gets deposited on a regular schedule. So you're adding to that principal, not through interest the way we did with compound interest, but actually adding additional funds there. So an annuity is just a sequence of payments made at regular time intervals. The time period in which the payments are made is called the term of the annuity. So the time period over which the payments are made is the term of the annuity. And we've seen this before when we were talking about compound interest and we were talking about the time, and I was telling you that the time is sometimes also thought of as the term. Okay. So different types of annuities have different types of names and the way they're described. So when you're talking about the term, one type is what we called a fixed time interval. And that annuity type has the name and a certain annuity, or an annuity that's certain. There are other kinds of annuities. We're going to be talking about this kind of annuities. But you can have ones that start at a set date but continue indefinitely. Those are referred to as perpetuity, if I can say it right, perpetuity annuities. There's also some that the whole term or the amount of time isn't fixed. It's not in perpetuity, but it's also not set. And those are called contingent annuities. So this is one of many types, and one of different characteristics of annuities have different ways in which we refer to them. So the payments that go into an annuity don't always have to be equal, but usually they are. And for topic 15, we're going to assume that the payments are all going to be the same amount. So for topic 15, we will assume that the payments are all the same amount. Okay. There are some examples. Let's talk about some examples of annuities. So a regular deposit is to a savings account. say, well, wait a second, I thought an annuity was this thing you go and see a financial advisor about and get all set up with. And that's true. Most people will refer to things in that way. Sorry about this light causing this big circle. Let me see if I can dim that. Oh, that's going to happen to me. Sorry about that. Right. Anyway, sorry. I hope you can read it. Okay, so regular deposits to a savings account. The essence of an annuity, the real definition is a regular deposits to a savings account. Okay, another one would be like monthly mortgage payments. So it doesn't have to be necessarily money that you're saving. It can be money that you're making, that you're paying something else or somebody else. So monthly mortgage payments would be a type of annuity. Or monthly insurance payments, something like that. So another way to classify annuities is by the payment dates. So you can make this payment either at the end of the period or at the beginning of the period. So payments made at the end of the period is what we refer to as an ordinary annuity. Okay, and this is also the kind of type of annuity we're going to be focusing on for this topic, for this section. All right, you can have some that are also, that the payment is made at the beginning of the period. These are called annuity due. And if the payment period coincides with the simple interest calculation, or sorry, not simple, but if it coincides with the interest calculation, then it's considered, let me write this down. So the other thing, so this is the second thing that we're focusing on. And then the third thing that we're thinking about, another aspect of an annuity that we're going to be kind of out of the whole world of annuities, we're kind of looking at a simpler case for right now, since this is the first time we're talking about this. And the third thing that we care about is if the payment period coincides with the interest calculation. So the payment period coincides with the interest. What's the word for it? Interest, I'm just going to say interest calculation when it's applied. Okay, and this is what's called a simple annuity. And once again, that's the kind we're going to be talking about. Now, you can also have ones that don't coincide, and those are called complex annuities. And as you can imagine, they're more complex. Okay, so when we talk about these kinds of annuities that are certain, ordinary, and simple, what we mean is the terms are given by fixed time intervals. Their periodic payments are equal in size, and the payments are made at the end of the payment period, and the payments coincide with the interest conversion periods. Okay, so let's do an example. Suppose $100 is paid into an account at the end of each quarter over a period of 3 years. $100 is paid into an account at the end of each quarter for over a period of 3 years. Okay, the account earns interest at the rate of 8% per year, compounded quarterly. So that's right here, compounded quarterly. Okay, so the first payment, so if you think about this, we're going to be talking about how many conversion periods. Well, quarterly is 4, so our M is 4, and our time is 3 years. So our total number of conversion periods is 4 times 3, or 12. Right? So the first payment is at the end of the first quarter. Alright, so I'm just going to say first Q, and it earns 0.08 divided by 4, which is equal to 0.02, right? So that's it. That's the interest rate applied for the quarter, and it's going to apply. There's a total of 12 quarters, but this payment is going into this account at the end of the first quarter, so it's going to accrue interest for 11 more quarters, right? So it's going to earn 0.02 for 11 quarters. Alright, because there was a total of 12, and we put it in at the end of the first one. So the first one's gone. So now there's 11 left. So, how much does that first deposit make for us? It's going to make $100 that we put in, and it's going to earn interest at this 0.08 divided by 4, or the 0.02, and it's going to go in for 11 quarters. So we're going to go and say that that's what we're going to do is say 1.02, and we're going to raise that to the 11th, and then I'm going to multiply that by 100. And I get that this comes out to $124.33. Alright, so after 11 quarters, that's how much that money made for us. Alright, so now let's talk about the second payment that's made. Okay, so the second payment works the same, but it's only going to be accumulating interest over 10 quarters because it's going in after the end of the second quarter. So 2 quarters are gone, 10 are left. So the second payment works the same. But only accumulates interest so we can figure out what that is, that amount. So let's call this amount one after the first quarter. A2 is after the second quarter. We're going to put in another $100 into this account, and we have this 1.02, but now it's raised to the 10th. All right, so we get an amount from this. And what is that amount? So I get that this is 121, so it's going to be a little less because it's only 10 quarters instead of 11. 121 and 90 cents. Okay, so now we kind of keep going doing this. And one way to kind of view this or think about it is if we were to draw a line that represents the quarters. All right, and we think about the payments that are made, and the periods of time. So we start at time 0, and after the first quarter, we're going to put in $100, and then after the second quarter, we're going to put in another $100, and then after the third quarter, so I should put 1, 2, 3. We're going to put in another $100, and this kind of goes on. So I'm doing that little break symbol. We talked about that, and we keep going. And at the 10th, let's say way out here at the 10th quarter, we're going to still be putting in our faithful $100. We put another 100 in at the 11th, and finally at the 12th, the end of the term, we put in our last $100. Okay, so what is the accumulated amount? Well, the very last one we put in doesn't accumulate anything, so it's just going to be $100. Okay? And the one before it was going to accumulate, it accumulates for 1 quarter, right? So it's just that compound interest formula applied to 1 quarter. So 1 plus 0.02 to the 1. All right, and then the one that went in at the 10th quarter, it has 2. So where I'm getting this from is this is the amount of time over which this one can accumulate is 1 quarter. Now, when we come in and we put in the one that we put in and deposited at the 10th quarter in this annuity, it has 1. And then 2 quarters to accumulate more interest. So it contributes 1 plus 0.02 squared, right? And so on. And if we remember back, we have this first amount up here. So that first amount, if I bring this down, I don't know if I'm going to have room for all this, is going to be $100 times 1 plus 0.02 raised to the 11th. And the one that went in at the second quarter, and that's $100 times 1.02. And remember, we said that goes in for 10 quarters it has to accumulate. And then the one that went in at the third quarter when we deposited this, and that also goes in for $100 times 1.02, but now it only has 9 quarters, right? So I'm just following this pattern, and so I'm going to put dot, dot, dot in between the first 3 quarters we put in, and the pattern continues. We go down all the way out to the 12th quarters. All right, so now that we have all this, how much money did we make? Well, we have to just add up all these amounts, right? We just add them up, and that's our total sum. All right, so the total of the annuity is this sum, S. All right, so it's just going to be the sum. I'm going to just put an arrow of everything we came up with prior to that, okay? All right, so whenever you have a sum that has a pattern, it's something that we call a geometric progression. All right, so these numbers like this is a geometric progression. And if you take calculus, depending, I'm not 100% sure if your calculus class will cover it, but a geometric progression, they probably will just because it's part of annuities, is a way to describe a sum that has a pattern, and then there's ways to come up with the answer of what that sum is in a formula. So that's what I'm going to give you. It's beyond the scope of this class. We don't have to, we don't necessarily want to derive the whole thing. I'm just going to tell you what that geometric progression is. Okay. So what we can say is that that sum would have been 100 for $100 times, I'm going to put big square brackets because it's a little complicated, and it's 1 plus the 0.02 raised to the 12th minus 1, and the minus 1 is not on the exponent, okay, divided by 0.02. And if we added all that, if we do that formula, you would match what you'd get if you added up all 12 quarters, the sum over all 12 quarters, and added them all up. All right, and what you would get is that this is going to be $13.41, rounded to the penny, $1,341.21. Okay. So in general formula, and this sum is what we call the future value of the annuity. So S, the future value of the annuity, so we want the future value of the annuity, okay, is given by this sum. Now what we're going to refer to these $100, we're going to refer to this using the letter R, because it's not really a principal anymore, right? It's a payment. So it's R, what you get for the first one, and now we're actually going to be counting backwards as to how many of these there are. So it's R plus R times 1 plus I plus R times 1 plus I squared, right, down here. Plus dot, dot, dot. We keep going out till we get to that one that was that corresponded to the very first deposit we made, which remember we could accrue for 11 quarters. So it's one less than the actual number of conversion periods. So our total number of conversion periods, remember, is 12 here. So we're going to go out to R to the 1 plus I, and we're going to raise it to N minus 1. Okay, so that's not the geometric progression. Well, it is a geometric progression, but we haven't identified the sum. We've just written it in mathematical notation to represent the way that we can see this pattern. Okay, so it turns out that you can derive this once you get to calculus. You can learn some techniques that R, that this is equal to R times this product of 1 plus I, it's the one I gave you right up there, raised to the N minus 1 over I. Alright, so that's the formula for the future value of the annuity. So we want to find the amount, so let's do an example now. find the amount